In this lesson, we're going to be talking about power functions, both with n equals -1 and n equals -2. Equations of the form y equals x to the n, the power function, where n equals -1 and n equals -2. Let's consider case 1, where n equals -1. Well, then y equals x to the -1, because our exponent is -1. And we can write that as y equals 1 over x. Now, if you plug in x's and get y's, which you can always do to graph, you choose the x and you get the y, you'll get a curve that looks like this, with a horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0. As x goes towards infinity, y tends towards 0 from above. As x tends towards 0 from above, we're getting closer and closer to this y-axis, y approaches infinity. As x approaches negative infinity, y approaches 0 from below, and as x approaches 0 from below, getting close to this y-axis again, y approaches negative infinity. The graph of y equals 1 over x minus k, so our difference here is we're subtracting k, where k is greater than 0, is identical to y equals 1 over x, but moved k to the right. Notice it's x minus k, and we're going the opposite of what you think, to the right. So we have a vertical asymptote at x equals k. The graph of y equals 1 over x plus k, where k is greater than 0, is identical to y equals 1 over x, but moved k units to the left. So it's x plus k, and we're moving to the left. And our vertical asymptote is, again, at x equals k. To illustrate that point, I have the graphs of y is equal to 1 over x, and y equals 1 over x plus 3. Well, in black, I have y equals 1 over x. It goes to the point 1, 1, and -1, -1. When I do y equals 1 over x plus 3, I'm shifting 3 this way. My vertical asymptote goes from x equals 0 to x equals -3, so I've moved the whole graph over to the left. Notice it's plus 3, and I'm moving to the left. Similarly, if I have y equals 1 over x and I compare it to y equals 1 over x minus 3, this minus 3 is telling me shift 3 to the right. So here's my parent function in black through 1, 1, and -1, -1. If I shift 3 to the right, my vertical asymptote goes from x equals 0 to x equals 3, and my point goes from 1, 1 to 4, 1, and -1, -1 to 2, -1. I've shifted 3 to the right. It's minus 3. X minus 3 tells me to shift. The graph of y equals the quantity 1 over x plus k, where k is greater than 0, is identical to y equals 1 over x, but moved k units up. There will be a horizontal asymptote at y equals k. The graph of y equals 1 over x minus k, where k is greater than 0, is identical to y equals 1 over x, but moved k units down, and there will be a horizontal asymptote at y equals -k. Here we have the graphs in black of the parent function y equals 1 over x, and y equals 1 over x plus 5. We see the horizontal asymptote went from y equals 0 to y equals 5. So 1 went to 1, 6, and -1, -1 went to -1, 4. For y equals 1 over x minus 6, we see that we have a horizontal asymptote at y equals -6. So 1, 1 went to 1, -5, and -1, -1 went to -1, -7. In each case, our vertical asymptote remains at x equals 0. Keeping on with this function, if I multiply that constant k, I think we can summarize quickly here that if k is greater than 1 and positive, I'm going to stretch. Here's my parent function. I will stretch my parent function. If k is positive but between 0 and 1, I will take this parent function and compress it. If my k is negative, the first thing I'll do, I'll flip this parent function over the x-axis. So that will put me in the second and fourth quadrants, and a -2 would flip me and then stretch me away, and a negative would flip me, and a 0.5 would compress me down. Power functions of the form f of x equals x to the n, case 2, where n equals -2. That puts us with f of x equals x to the n, while n is -2, which means f of x equals 1 over x squared, because this exponent just means I'm in the wrong place. Put it down below. If you don't know what this looks like, with all the functions, including this one, you can pick x's and get y outputs by putting these x values in for x and finding what your output is. When I do that, I get a shape that looks like this, and we call this the truncus function. Notice there is a horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0 for this parent function. If you're watching this video, this should come as no surprise that our observations are that the graph of y equals 1 over x minus k in parentheses squared, where k is equal to greater than 0, is identical to our parent function, but move k units to the right. It's minus associated with the x, and it's the opposite of what you think. A minus k sends us to the right, and the graph of y equals 1 over x plus k squared, where k is greater than 0, is identical to our parent function y equals 1 over x, but move k units to the left. So we have plus k moving to the left, with a vertical asymptote here at x equals negative k. If I have my parent function y equals 1 over x squared, I have a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. Y equals 1 over x minus 3 squared moves me 3 to the right, so I have a new vertical asymptote at x equals 3. Y equals 1 over x plus 4 squared moves me 4 to the left, so I have a new vertical asymptote at x equals negative 4. In all three cases, I remain with y equals 0 as my horizontal asymptote. The graph of y equals 1 over x squared, that quantity plus k, sort of separated from this 1 over x squared, where k is greater than 0, is identical to the parent function y equals 1 over x squared, but moved k units up. So our horizontal asymptote has moved up from y equals 0 to y equals k. Similarly, the graph of y equals 1 over x, the whole thing minus k, where k is greater than 0, is identical to the parent function y equals 1 over x squared, but moved k units down. So our horizontal asymptote goes from y equals 0 to y equals negative k. Here we have a truncus function, parent function y equals 1 over x squared, demonstrated here with horizontal asymptote y equals 0, vertical asymptote x equals 0. In blue, y equals 1 over x squared plus 4 moves my horizontal asymptote up to y equals 4. Similarly, in green, y equals 1 over x squared minus 3 moves my horizontal asymptote down to y equals negative 3. We could multiply this power function with n equal negative 2, which gives us a parent function of y equals 1 over x squared, by a constant. If our constant is greater than 1 and it's positive, for example, if k equals 2, you can imagine that we're going to be stretching this function out along the y-axis. If our k is positive but between 0 and 1, you can imagine we're going to squash this down along the y-axis. If our k is negative and less than negative 1, so its magnitude is great and it's away from 0, then first we're going to flip this over the x-axis and then we're going to stretch it down. And if k is negative, that means we're going to flip it over the x-axis again. But it's between 0 and negative 1, that means we're going to squash it down towards the x-axis.